I've just about finished my aircraft and I'm looking at engines. I've worked on a lot of auto engines and I'm just wondering, do I have any other choices?
Since the individual that's using an Aerovee engine has assembled it, he knows the engine in and out. One of the things is that it uses a tremendous number of off-the-shelf parts, so that those will be readily available. Even if Aerovee goes away, the company, those parts will be available for years and years to come and through many, many suppliers. The individual rebuilding engine or needing to rebuild the engine or do an annual on it will find that the cost of those parts is very, very low compared to anything in the aviation market. So that's, again, a value for dollar in time. The luxury now is that we have had time to develop a new division and a new conversion system based on new technology. In the past, we used to use a lot of conversion parts for the VW that were castings. Now we use billeted parts that are CNC machined. They're much prettier parts, they're much stronger parts, and it allows us through CNC machining to make changes as we go along with improvements, and we've done that. Prop hub that is a shrink-fit prop hub, but a much beefed up version. It has an intake manifold system that is developed specifically for our conversion. It uses the new Aerovee carburetor, which incidentally we use on all of our engines, including the 2200 and the 3300 Jabiru, as well as the VW. And on the back of the engine, we have a new X casting that not only provides the shock mount for the engine, that's the normal vibration rubbers that you'd find on a Continental or Lycoming, but it also includes a built-in alternator, a geared starter, and an ignition system that's quite unique.
Aero Conversions Incorporated is proud to present its Aerovee 80 horsepower engine kit. The engine represents over 3 years and thousands of hours of engineering, research, development, machining, and testing. Our design team has over 30 years experience in pioneering and innovating VW-based engine conversions. The kit includes all of the components necessary to complete the state-of-the-art aircraft engine.
Welcome to the world of William Wynn and Corvair power for aircraft. We will show you the details necessary to understand how easy and affordable it is to fly behind the very reliable and still plentiful Corvair engine. Many happy hours of flying for you and your project are just around the corner with William Wynn's Corvair engine conversion for aircraft. This can be you, taking your first flight behind a true 100 horsepower Corvair conversion built by your own hands, which allows you to have the repairman certificate to maintain your engine throughout the coming years. Right now, let's head to the hangar near Daytona Beach, Florida, where William Wynn will show you more about the Corvair engine conversion for aircraft use.
Good afternoon. I'm William Wynn. This is Phil Maxon's Zenith 601 XL. Of course, it's powered by a Corvair engine. The firewall forward installation was done here at our shop. Phil did all the workmanship on the airframe. This particular combination of the Corvair engine on the 601 airframe makes an excellent LSA aircraft. It has many advantages that people are interested in. Affordability is the primary goal of this combination, and it is achieved. This airplane is amongst the least expensive of all LSA fixed-wing candidates. But importantly, it's an excellent flying airplane that meets the expectations of today's LSA builders. We've been working with Corvair engines for more than 10 years commercially. Phil's 601 is just the latest in a long line of aircraft powered by Corvair engines. Our own 601 XL, which pioneered the installation of the 601 to Corvair match, has more than 300 flight hours and has flown more than 75 passengers. Phil's airplane represents how we teach people to do this combination themselves. It's an excellent example of what type of an aircraft home builders can build their first time out. As you look at the film, take a good look at the aircraft and realize that it is an airplane that any home builder would be proud to have created. It's a simple aircraft, certainly within the reach of any determined home builder. The Corvair engine provides an affordable power plant. Beyond affordable, the power plant meets the expectation of LSA builders. It provides excellent performance all the way to the limit of the 120-knot cruise speed of LSA aircraft. The XL is a very efficient airframe and requires very little power to achieve this. Typically, this aircraft will cruise at 130 miles an hour at 5 gallons an hour. The Corvair engine's equally comfortable burning 100 low lead or 93 octane auto gas. Even though this aircraft was built from a kit by Phil Maxon, and he purchased virtually every product we make for the Corvair engine, the airplane as you see it today is well under $30,000. This represents one of the least expensive routes to a quality fixed-wing aircraft in the LSA category. Join me now for a look at some of the technical details on the firewall forward package. It represents more than a decade of developing skills and techniques on our part to perfect the installation into the 601 airframe.
The very front of the aircraft sports a very large 13-inch spinner. Combining this with a lightweight pre-preg composite nose bowl gives the 601 XL its hallmark indication that it's Corvair powered. This sleek construction with round air inlets is very heat stable and provides more than adequate cooling for the Corvair engine. Directly behind the nose bowl is sheet metal construction that makes up the rest of the cowling. Access to the engine compartment is accomplished from either side with a few cam lock screws. This allows easy access to the upper portion of the engine for inspection and pre-flight. The lower half of the cowling can easily swing down for complete access to the engine during scheduled maintenance. All the components for the cowling, nose bowl, spinner, and sheet metal templates are available from flycorvair.com. As we look into the engine compartment, we can see that it's a clean and functional installation. Rubber baffling is used in the traditional fashion to seal the motor in order to force cooling air from the inlets through the engine. The Corvair engine has an incredibly high 575 Fahrenheit maximum operating temperature. This is hundreds of degrees higher than other air-cooled engines, providing tremendous reserve cooling potential. Here you can see the dual ignition points-based distributor developed by William Wynn for the Corvair conversion. Even though this is a points-based system, it requires very little maintenance and is extremely reliable. With dual coils, condensers, and 2 sets of points, it should only require an annual points inspection. The ignition coils, condenser, and automatic coil switcher are behind the firewall to protect them from the heat in the engine compartment.
All 601XL installations use redundant electric fuel pumps. The fuel pumps can be seen in series on the firewall here. Whether the aircraft is equipped with a Marvell-Chevrolet carburetor or an Ellison throttle body injector, the fuel pump installation is the same. Although the Corvair engine is traditionally thought of as an inexpensive power plant, and it is by comparison to most other power plants, we never use cheap components when installing it. All the details on the aircraft, as you see it here, are AN quality. Take a look at the gascolator. It is an Andair gascolator, an excellent mechanical product out of England. It is more expensive than other gascolators, but it offers significant quality. When we take a look at Phil's installation a little closer, it is set up for an Ellison EFS3A throttle body injector. On the 601XL, we either use this or a Marvell-Chevrolet certified aircraft carburetor. On installations involving flight engines, I shy away from using motorcycle or motorcycle-type carburetors because I like to use purpose-built components. Although the engine has an automotive history, through extensive work, we've turned it into an aircraft power plant. And many of the things that make it an aircraft power plant are related to the detail quality on the installation. The exhaust system that we manufacture for the 601 is 304 stainless steel. It has an infinite lifespan on a Corvair installation. Notably, the pipes themselves are bent on a CNC pipe bender. This produces a single unseamed joint throughout 90% of the pipe's length. The stacks themselves are machined from CNC billets of 304 stainless. Likewise, the intake manifold that connects the carburetor mounted below the engine, as a traditional aircraft style carburetor always is, to the intake manifold on top of the engine. This component here is made also from 304 stainless. The Corvair uses a bed-style motor mount. The components you see in blue are 4130 steel, TIG welded here in our own jigs to provide a perfect match between the 601's airframe and the Corvair engine. With the intake manifold on the top and the exhaust system on the bottom, it's easy to see that the Corvair engine has a cross-flow cylinder head. Cross-flow cylinder heads, especially on air-cooled engines, are far better performers than non-cross-flow heads. Modern aircraft power plants like Continental's IO240 utilize this same design. Although the Corvair is an older design, it has many features that General Motors included that were well ahead of its time, such as the cross-flow cylinder head, hydraulic valve lifters, and a torsional vibration dampener available on all engines. One of the greatest things about Corvair engines is their accessibility to home builders. All the components we're looking at and talking about today are available individually. No one needs to be able to mortgage the house to ante up to buy an engine. All the pieces can be bought, purchased, or created separately. All of our work is based at helping the maximum amount of people achieve their dreams of aviation. Everybody's got a different budget, and the Corvair is here to serve people from the most modest of budgets straight on through people who wish to purchase a completed engine from us. Here's the pilot's side of the engine installation. On this side, you can see the cabin heat muff on the stainless steel exhaust system on this side. Over here, we have the firewall mounted high-performance K&N oil filter. Although it's of an automotive nature, it does include a safety wire tab and a nut, just like a Champion oil filter. The lines that feed the oil filter housing, all AN. These tubes here are for the highly efficient air oil separator. Again, the stainless steel intake on this side with the rubber coupler and the Corvair's cross-flow cylinder head. This is Rick Lindstrom's 601XL. The aircraft was built here in our shop in Florida, and the engine installation, the engine build was done here also. It represents perhaps the finest installation of a Corvair engine into a 601XL airframe to date. Well, it is a nice job. All the components that we make this well within the reach of average builders. Even if you're working just from a plans or components standpoint, this engine installation is accessible to you. Rick's engine represents a 2006 production engine in our shop. The distinguishing characteristics of these engines are that they have Falcon cylinder heads, which are designed to use either 93 octane or 100 low lead fuel interchangeably. If you look off the end of my finger, you'll notice that this has ARP case studs and ARP head studs installed. This first-class hardware improves the already tough performance of the Corvair. Of course, it has our standard ultra-low profile electric start system. And coming around this side, you'll see the John Deere dynamo, the alternator bracket that we make and sell. It's a CNC hydrocut piece. Right here, many people ask, that is the tachometer pickup. This small magnetic pickup counts the teeth on the ring gear and works with a Stewart Warner tachometer or an IK electronic box and gives you extremely accurate tachometer information that is entirely divorced from the ignition system. The black baffling on this motor lacks only its rubber stripping that would touch the cowl and complete the seal. This baffling we have templates for, and its simple installation is riveted together just like the regular structure of the airplane. It's made out of 25,060/61 aluminum. The spiral wound to cell wires are absolutely noise-free with any type of radio that we've ever flown or tested. As we go a little further back, this engine mounts a brand new Niagara 2002 oil cooler on it. The 2002 is the Super Duty oil cooler for Corvair engines. It's run by remote line, AN6 Earls fittings. The cooler is in basically the same location as the stock cooler, but it's plumbed slightly differently. For aircraft operated in desert or hot tropical environments and subjected to continuous climbs, this is a desirable option. Of course, the Niagara cooler is brand new and perfectly clean on the inside. This is our standard remote oil filter housing and of course the high quality KN filter. But sandwiched in between is our Permacool remote oil cooler adapter. This contains a thermostatic bypass. The bypass in it allows the cooler to be bypassed just as General Motors designed it to function. It has 2 more lines to it that come up to the oil cooler itself. This system is perfectly tested and we've got it on about 5 flying airplanes right now. It'll drive the oil temperature down below 200 degrees measured before the cooler. That's a lot of cooling. In many cases, in any weather other than tropical weather, you'll have to block off some of it. But many people like to have the coolest oil temperature possible. The instrumentation seen here on the oil filter housing for temperature and for pressure is set up for the IK Technologies EIS, the Engine Information System. They are my preferred supplier for electronic instrumentation. The Corvair is perfectly capable of using either inexpensive automotive steam gauges or using high-end electronic instrumentation. The bottom of the engine is our ultra-lightweight deep sump aluminum oil pan, manufactured right here in-house from CNC subcomponents. This pan holds up to 6 quarts of oil. The pan weighs less than the stock steel pan does. Behind it we can see that Rick's airplane is equipped with an MA3 carburetor. And on either side, the stainless steel 601 exhaust system. How long it takes to install an engine and how reliable its performance is often determined by the detail of the design and the installation. If you look very closely at the engine, for an amateur builder, it's much easier to work with an engine where there is available information on how to put on every single line, clamp, and baffle. Just looking at the firewall pass-through line on this particular installation, our installation manual covers the length of the wire, the number of the ADAL clamps, the type of insulation here, the length of the screw, all the information, including the number of the firewall pass-through and where to order it. We're here to support anybody who needs just to know where to get the stuff, or how to make it, or provide it as a done piece.
Overhead, it's the familiar sound of another Corvair-powered airplane in the pattern, and we head out to see who it might be.
This is one of my favorite Corvair-powered airplanes. This is Bill Clapp's KR2S. It has a very standard 2700 cc, 164 cubic inch Corvair motor in it. The airplane itself is a tribute to Bill's ability as a builder and a scrounger and a craftsman. It's got less than 8,000 bucks total in the airplane. He built it in about 18 months of part-time work. Getting a good look at it, it has about $3,500 ahead of the firewall. That's a very, very affordable engine option for a KR2. Bill's airplane features many of the parts that we make for KRs. His cowling is a purpose-built and designed cowling that mates the KR2 airframe and the Corvair motor together. It has the classic look of the round inlet Corvair cowling that you see on other aircraft, but this cowling is an entire fiberglass top and bottom unit. We have molds built that make it fit this airframe just like a glove. This cowling works with motor mounts, exhaust systems, and all the other components that we make, like intake manifolds, to make your installation of a Corvair motor into your KR a lot easier.
If you would like to learn more about Corvair Power by William Wynn, go to flycorvair.com on the internet. There you will find contact information and a complete overview of the conversion products. William Wynn has assembled a group of experts in related fields that is the Hangar Gang. At any time, they can be called upon to deliver high-quality craftsmanship to most any situation. The Hanger Gang is ready to serve your needs today.
My name is Steve Bennett. I'm the president of Great Plains Aircraft. We've been in business since 1982 supplying VW-based engines for sport aircraft. We'd like to show you what's available today, the engines, the options, and the accessories. VW-based engines have been used in home-built aircraft since the late 40s. They have almost a 70-year history of powering home-built aircraft. There's many different styles of motors that we were able to use, starting from the smallest 1600 cc clear up through 2180 cc's. Horsepower range goes from approximately 50 to 80 horsepower on direct drive motors and 80 to 103 horsepower with a reduction drive motor. And we also have liquid cooled cylinder heads available, which gives you, with a reduction drive, up to 120 horsepower. We've been in business since 1982 and have exhibited at Oshkosh and Sonnenflug since 1984 continuously. We are probably the largest VW supplier of engine kits and parts in the world. To date, we've sold several thousand motors in addition to the engine kits and engine parts to customers literally worldwide. We ship internationally every single week. One of the main advantages of using a VW engine in your home-built aircraft is, of course, cost. The least expensive Volkswagen engine you can purchase, which is a direct drive 1600 cc motor, you can build from a kit for less than $3,000, and that's for a brand new engine. Contrast that to the most complicated motor we have in a direct drive form, which would be our 2180 direct drive engine with the accessory package on the back, starter, alternator, assembled. That engine goes out the door with dual ignition for about $6,500. You can contrast that to some of the other engines available in the marketplace, the Rotax and the Jabiru, and you can pretty much buy a Volkswagen-based engine of comparable horsepower for half price. VWs were last imported into the country in 1979. The days of going to the junkyard to find a good VW engine out of a car that just had a front quarter hit or the front end hit are pretty much done with. In a junkyard, if you find a VW engine in a junkyard anymore, it's usually there because it's truly junk. Our engine kits are all supplied with 100% new components, with the exception of the smaller engines which use the stock VW crankshaft, which is a reground crank. Other than that, all the components are new. The engine case, the cylinder heads, pistons and cylinders, everything in the engine is 100% new part. The parts are still made in Mexico, Brazil. A lot of them are made in Japan, in the U.S., because there's such a huge aftermarket for the motor yet. So parts availability is just not even an issue. The way we have our company structured is that you can buy an engine part, you can buy an engine kit, or you can buy a complete test run and assembled motor. It's really just up to you. Kind of depends on the customer's skill level, if you're comfortable working with motors. Some people you can coach into it, and some people just don't want anything to do with it, of course. That's why we offered an assembled and test ran motor. And we're talking a little bit about cost of a VW motor. This engine here is a 2180. It's going to have a 1.6 to 1 reduction drive on it. It's going in a World War I vintage type aircraft that uses a large propeller. This engine here is a single ignition model, and the entire motor will run about $6,000. That's fully assembled and test run. All the components in this engine are 100% new. The engine case, the pistons and cylinders, the cylinder head, the valve train, everything in it is 100% new. And that's one of the great strengths the VW motor has to offer, because there's such a large aftermarket parts base for the motor. There's many manufacturers that currently make parts for the motor, even though the car itself has not been made since 1979. An example of that would be the cylinder head that's right here. This is a brand new VW cylinder head. Comes complete with valves, valve guides, springs, keepers, everything. This cylinder head here retails for $140 brand new, and that's per head, but it's $140 for an entire cylinder head. We also have the option, if the customer wants it, as you can see here, to put dual ignition in the cylinder head. So you have true dual ignition for your engine. You have one magneto and one electronic ignition to keep your engine chugging along. Direct drive motors make up most of the engine sales because that's what most of us are familiar with. Most of the popular airplanes, the KRs, the Sonorais, the Sonex, they're all direct drive based motors. They're going to be driven one or two of these styles. We have reduction drive based motors, which is what this engine is here. This is a 1.6 to 1 drive. We have the drive pulley here, and the driven pulley will mount up here in the top. The advantage of this engine over a direct drive, this engine here, a 1.6 to 1 will swing a 72-inch prop. A 72-inch prop, in terms of static thrust compared to a 60-inch prop, you're looking at 350 pounds for the 1.6 to 1 redrive versus 200 pounds for a direct drive motor. So you get, just so much more thrust by swinging a bigger prop. We can go to a 2 to 1 redrive and use an 84-inch prop, which will do around 425 pounds of thrust. Or we can go to a 2.47 to 1 drive, swing a 96-inch prop, which will generate just under 600 pounds of thrust. Looking at comparing motors, you can't just look at the horsepower number. You have to look at how the horsepower is transmitted to the propeller. For example, if you're looking at an engine installation, say a Zenair 701, an 80 horsepower Volkswagen that's direct drive is not going to fly that airplane. Why? Because it does not have a large diameter prop. We do have a package for 701s. We have a motor mount, of course, then we have the engine for it that we supply so that you can bolt a VW on a 701 with a 1.6 to 1 drive. But if you're looking at something that uses a Rotax in general, a direct drive Volkswagen is not going to be comparable in terms of performance simply because it lacks prop diameter. So if you're looking at something with a gearbox on it, you're pretty much going to have to look at a Volkswagen with a gearbox on it also. On direct drive motors, we have two basic ways to attach a propeller to the crankshaft. This here is what we call our standard shrink fit prop hub. The end of the crankshaft here is about 2 thousandths smaller than the end of a standard VW crankshaft. This prop hub is heated up to roughly 450 degrees, and then it literally slips onto the crankshaft, engaging the end of the crankshaft this far. It's about 7/8 of an inch. This same prop up here is made as a tapered prop hub also. To use this as a tapered hub, of course, the end of the crankshaft has to be tapered to match the 3-degree taper of the prop hub. We use this style prop hub only on the stock 69mm crankshaft, which gives you engine displacement up to 1915 cc's. The other style of prop hub we have is called our Force 1 prop hub, which is right here. The advantage of the Force 1 prop hub, it's on a taper. As you can see by looking at these two cranks side to side, the shrink fit hub is engaged about 7/8. The Force 1 prop hub engages the length of the taper right here. It's almost 2 inches. Actually, it's a little better than 2 inches, I believe. So it's got over twice the area of engagement. And when you add that in with the radius and all, it's quite a bit more than that in terms of area. The other advantage of this style hub is we have to machine the case out for the bearing right here, the nose of the case. So what that does, instead of having the prop hub ride forward of the bearing as it does on the standard crank, this is your bearing area, you now have the prop hub supported by a bearing. So that the entire hub is not forward of the bearing with an arm moment. It's actually being supported by an oil lubricated bearing that's installed in the engine case. This engine here is our rear drive engine. The benefit of the rear drive, it's driven off the flywheel end of the engine, but inside the housing is a torsional dampener. Then we have a drive shaft that comes out that's supported by a bearing in the front. What the system does, the torsional dampener does the driving off the flywheel from 3 lugs, and it actually floats on the 3 drive lugs. Then the drive hub from the drive shaft goes inside the torsional dampener. So all the propeller loads are really taken care of in the housing and the torsional dampener, and they're not transmitted back to the engine case. In the crankshaft, the carburetor mounts on top of the motor, and so you get a real nice low profile intake manifold. We use the Ellison EFS3 on top. Then on the back of the motor we've got a 40 amp alternator that's belt driven off the same pulley you'd use in the VW car. This engine is equipped either with single ignition or dual ignition. It's just a builder's option. We also have a flywheel drive engine. It's just as it describes. It's a flywheel that has a prop hub attached to it, mounts here, and it's driven off the flywheel into the motor. It's that simple. We mill the top of the case off right through here, and we have a starter that mounts on top of the motor that goes backwards towards the pulley. It's a very simple installation. It's probably the least expensive motor we have. The flywheel drive 2180 complete engine kit runs about $4,800, and it's also the lightest. That engine weighs 158 pounds. A direct drive Volkswagen off the other end of the motor with the accessory package 1 and 6, which is single ignition magneto plus the distributor drive housing for your secondary. That engine weighs 164 pounds. Reduction drive motors weigh 188, and the liquid cooled motors, by the time you have the coolant, they weigh right at 200 pounds. This here is a deal accessory case. Again, it's one of the strengths the motor has to offer. We have this case. We also have an X pattern, and that does not have a starter boss on it. And then we also have a single mag drive, which we can show you in a little bit. The starter mounts down here in the bottom at 6 o'clock on this case, but this case is also available with the starter at 9 o'clock and the starter at 12 o'clock. You can't interchange the cases because the bolt pattern on the back of the VW engine case is not square. Inside the accessory case, what we stick on there is the magnet ring that's right here, which goes on the back of the flywheel. That rotates. Then we have the stator, which is this part. This mounts inside the accessory case right there. This is a 22 amp alternator, which is standard in all of our kits. And when it comes to mounting the motor, we have a number of different options available. First, we talked about the deal accessory case, which we showed earlier. Deal have available what's called the X casting, which is this unit here. This unit here mounts the magneto, of course, in the center. The 22 amp alternator is inside, and it mounts on the back of the case like that. There's no starter with the X casting. It's just a very lightweight way to mount your motor. Lots of different carburetor choices for your engine. What we sell is it's a Zenith updraft carburetor. It has a little T-handle on the back for mixture control. On the reduction drive motors, we use a downdraft Weber. It does not have mixture control. Most cases it's not an issue because the builders that fly this type of motor in the airplanes, if they get above 2,000 or 3,000 feet, it's a performance day. Other carbs available, there's the RevFlow from RevMaster, which it's not a true injector carburetor. It's just a carburetor that has a slide in it with a needle, and the fuel comes out, but it's not an injector. Then there's the AeroCarb, which is the same type, and then there's the old POSA, P-O-S-A, and all those carbs are in the same veins that they call them injector carburetors, but they're really just a carb. You know, one of the other options we have for Volkswagens in the recent years is liquid-cooled cylinder heads. This makes this engine very comparable to a 912 Rotax. The cylinder head is all liquid-cooled, and of course the cylinders in the block are still air-cooled. Direct drive with the liquid-cooled heads, this engine will produce right at 100 horsepower. With the reduction drive, because it's a higher RPM motor, it'll do a little better than 120 horse. Of course, that's takeoff horsepower, and it's not sustainable forever. If you look at this cylinder head here, you can see the intake port design is vastly larger and cleaner than what a standard VW engine is. And also, it has very large intake valves and exhaust valves. They're 42 millimeter intakes and 37 exhaust. The flow through the head is really excellent. This engine here uses a 40 millimeter Bing carburetor, constant velocity, where your direct drive motors will use a 32 millimeter carburetor. So you can kind of get an idea there of how much more flow this engine's capable of. Looking for dual ignition in the motor, we have true dual ignition in the engines. That's 2 spark plugs per cylinder. One is usually driven by a magneto and the other by electronic. That's not possible in all cases, of course. On this motor here, if this were liquid cooled, the water pump would drive off where the magneto goes. So if you'd want dual ignition, we have to do 2 electronics. So what we have to offer, you'd have the distributor up here for once. You can use electronic versus a distributor, that's your choice. And for the secondary ignition, we have what's called our oil pump electronic secondary ignition. And all this simply does, this is an oil pump cover plate that we manufacture. It replaces the standard VW oil pump down in the motor. and it's driven by a drive tang that's milled into the lower drive gear on the oil pump. Very simple, just all electronic, just right here. Or you can time the electronic ignition simply by moving the housing here. You can go about 10 degrees in either direction. More common way we do electronic ignition is with this unit right here, our secondary ignition housing. There's a shaft that goes in here that sticks out about another inch or so, and this housing is installed right where the standard VW distributor goes in the motor. This would be your secondary ignition, and on the back of the engine here where the accessory case mounts would be the magneto, which is your primary ignition. This ignition here you cannot have turned on when you start your motor because it's preset to 28 degrees before top dead center. So you want this off. Once your engine's running, you flip this switch on and you just leave it running all the time. On VW motors, we typically do not use a muffler per se, as you see on a car or in certified aircraft. What we have are 4 straight pipes, or we have a 2-into-1 exhaust system where the front 2 cylinders tied together and exit, and the rear 2 cylinders tied together and an exit. Or we have available 4-into-1 systems for the KR series of home builds. We also have a U-build exhaust system, which is very popular for a lot of builders. It costs about $100, and it's all the mandrel bent pipes and slip joints so that you can craft your own exhaust system.
Yeah.
For instrumenting your motor, you really just need the basics. Sometimes we'll find that builders install too many instruments on their airplane and they can get overloaded. You don't need 4 EGTs or 4 CHTs, just one. On the CHT, you can buy the kind that either goes under the spark plug. What we recommend builders do is, though, they install it under the cylinder head stud washer that's right here. If you average out all the temperatures on the motor, this of course is going to be the hottest under the plug. But if you average them out, one of these 2 studs here is the average temperature of the cylinder head. That way, if you install it here, you also won't be tearing up your bayonet each time you take it on and off your plug. Underneath the stud here, your temperature should run 275 to 300 in cruise, with about 325 being the max. Instruments wise, you're going to need an oil pressure. The oil pressure is installed right here in the engine. They can either be mechanical, or you can run a line back to the cockpit, or you can use electrical. And then down here on the side of the case, it's probably hard to see where you're at, but down here in the oil sump area is where we would put the oil temperature probe. In addition to that, you're going to need a tachometer. It can be just a simple inductive type that wraps around one of the spark plug wires, or they have the kind that goes on to the magneto P-lead, or we have another one that counts the magnets in the magneto as the mag rotates, so it counts that way. It doesn't take a lot of special tools to assemble your motor. As you can see in the background here, it's just your common tools that most of you have already. About the only exceptions would be up here. You're going to have a 36mm socket for the gland nut, maybe a 30mm socket for the bolt. And we have a few specialty tools like this that you can purchase from us, or you may have. This is a flywheel lock. And over here we have a distributor drive pinion gear puller. But it really doesn't take anything special at all to assemble the motor tool-wise. We have a little toolkit we put together. If you want all those tools, it runs about $125 if you don't have them. But in the cost of a motor, it's pretty minor. For those that wish to assemble the motor, what we have here, it's a 64-page assembly manual, and that is mirrored by our 2 DVD set of, and it's an assembly video. This video mirrors pretty much page for page what the assembly manual does. This is about 4 hours long. We get asked a lot, what is the TBO of a Volkswagen motor? And why not to be snide back to someone, there is none. It's a non-certified engine. They're installed in non-certified aircraft. Every builder has their own idea of what's perfect. And so thus, even though we provide a baffling manual and installation guidelines, it's rarely followed to the T as to what we provide. And because of that, you can have 2 airplanes side by side, Builder A and Builder B. Builder's A engine may go 2,500 hours and Builder B engine may go 50 hours. And it really has to do with the way the engine's installed and the way the engine's used. Another example of that is we recommend builders use a manifold pressure gauge in their engine. They say, well, everybody flies at 3,000 RPM, don't they? And pretty much true. VW motors usually cruise between 3,000 and 3,100, 3,200. But what you don't know without a manifold pressure gauge is what percentage of power you're extracting from your motor at that setting. As an example, if your engine's overpitched, builder A again may be cruising at 3,200 RPM at 23 inches of manifold pressure, and while builder B may be cruising at 3,200 RPM at, say, 27 inches of manifold pressure. So builder B is running a whole lot harder than builder A is, yet he thinks he's doing fine running along at 3,200 RPM. So a manifold pressure gauge, especially on a new aircraft, is something you really want to install in your airplane. It's the best way to see if your prop is set right to match what your engine's doing. At Great Plains, we stock about 93% of all the components you'll find listed in our catalog. We have all the small stuff, the main bearings, the dowel pins, the nuts, the bolts, all the stuff necessary to assemble the motor, including the engine cases, a little larger stuff, the piston and cylinder sets, the cylinder heads, the intake manifolds, carburetors, the exhaust systems, the exhaust parts. All that stuff we pretty much carry in stock all the time. What takes time that we don't stock are the exhaust systems and the motor mounts, because they're just not sold as many of as the other common parts are. If you'd like more information on our company, you can just go to our website. Our catalog is available on the front page in PDF format. You can download the entire catalog or just whatever pages you wish. We also have the old-fashioned mailed version out for $4.
My name is Pete Crotty, and I'm Chief Manager of Jabiru USA Sport Aircraft. We're the largest distributor of Jabiru aircraft and engines in the world, and today I want to talk about the Jabiru aircraft engine. Currently in the world there are over 3,500 Jabiru engines flying. Another 500 or so are in airplanes that are being constructed. Right now, Jabiru is producing at the rate of about 600 per year. That is about to be increased by 50% due to increasing worldwide demand. By the middle of next year, Jabiru will be producing at the rate of about 1,000 aircraft engines a year. Overall, around the world, there are over 1,000 Jabiru airplanes flying, all powered with Jabiru engines. They figure at least half of those are being used in flight schools or flight clubs for flight training, and they're building up a lot of hours in a hurry. The flight training fleet in Australia consists of nearly 200 Jabiru airplanes, and that fleet has accumulated over 500,000 fleet hours now. So Jabiru's had a good chance to look at long-term performance of their engines. The highest time Jabiru airplane has now just ticked over 8,000 hours in a flight training school in Bundaberg, Australia. That engine was powered by one of the original four-cylinder engines, and that has been replaced with an engine that now has a little over 4,000 hours on it. And is still going strong, flying touch and goes with students every day. Let's talk about some of the technical features of the Jabiru engine, which sets it apart from most other aircraft engines out on the market. Number one, as you can see here, it's a marvelous piece of machining. All the parts on the Jabiru engine, with the exception of the oil sump, are all carved out on a CNC machine from billet aluminum or steel bar. The heads that you see here begin life as a square piece of aluminum billet. It's put in a CNC machine. That machine carves out the fins, drills all the holes for the spark plugs, and makes this head out of just one solid piece of aluminum billet. The cylinder barrels, by contrast, are made of 4140 steel. These begin life as a 7-inch diameter bar of 4140 steel. They're put in a CNC machine. The first procedure is to cut the core out of the cylinder barrel, and then that core is hung on a tooling board, and a connecting rod for the piston is made out of the core of the cylinder. And the CNC machine finishes cutting the fins on the head, making the bore, cutting the base of the cylinder barrel, and all the other operations necessary. As you can imagine, when it's all done, we have a very nice looking piece and a big pile of chips outside the CNC machine. The crankcase is machined again out of a solid billet of aluminum. It's a two-piece crankcase split right in the middle. No gasket is used when that's put together, and they don't leak oil. It's just a metal-to-metal fit. After the crankcase is carved out, Jabiru puts it in a very sophisticated measuring machine, and they measure 400 different points on the crankcase. That information has to all meet the tolerances that Jabiru has established, and then the information is saved in the computer, and if an engine ever comes back to Jabiru for rebuild, they put the crankcase back in the measuring machine and measure those same 400 points and see what has changed. And this machine measures down within 1/10,000th of an inch. Other common parts used in the Jabiru engines, both in the 4 and the 6 cylinder, are sourced from the automotive industry. The pistons that are used in Jabiru engines actually originated from General Motors, and you would find a similar piston in the US in the Buick, Oldsmobile, Pontiac V6, the 3800cc V6. They are not off the shelf, however, because Jabiru does machine a third ring groove in for an oil scavenger ring, and they deepen the circlip holes and use stronger circlips to hold the wrist pin in the piston. So while it's sourced from the automotive industry, it is not an off-the-shelf item. Rings, they are an off-the-shelf item. One of the advantages of Jabiru, when you rebuild the engine, our rings cost $15 per cylinder for the complete set per cylinder. Compare that with some of our competition whose rings are $60 for the bottom ring and $70 for the top ring. As you can see, Jabiru can be rebuilt a lot more economically. The connecting rods inside there, again, are made by Jabiru, machined out of the core from the cylinder. The connecting rod caps are again machined out of 4140 steel. The crankshaft inside here is all one piece. It is not a pressed together crankshaft. It is machined out of, again, that 7-inch diameter 4140 steel bar. In the machining process, the crankshaft is balanced, and then when it's installed in the engine, there is a main bearing between every cylinder. There are no flying webs on this crankshaft. So the 4-cylinder engine, for instance, has 6 main bearings. It has 1 at the back, 1 between each cylinder, and 2 at the propeller end. The 6-cylinder engine has 8 main bearings. Again, 1 at the back, 1 between each cylinder, and 2 at the propeller end. So the crankshaft is very strong, very stiff, and very well supported. Bottom end on Jabiru's lasts 4,000 hours usually without, if the oil has been kept at the right temperature and changed regularly. The bottom ends on Jabiru's last 4,000 hours with just a bearing change. Okay, some other technical features of the Jabiru engine. Let's start with the ignition system. The spark is generated by a magneto in a magneto module. Doesn't look anything like the conventional aircraft magneto, but that's this little black box right here. That's manufactured by Honda, a Honda design, and again, part of Jabiru's philosophy is to use technology that's available, and these magnetos are available all over the world for a relatively modest price. There are 3, in the case of the 6-cylinder engine, there are 3 magnets on the flywheel, and as they go past the magneto, it excites a coil in there, and then solid-state circuitry takes and condenses the spark and feeds it down to a distributor cap, which hopefully we can see down here. This is an automotive distributor cap. I believe it's off a Nissan V6. You can get those at most auto stores if you need to, or you can get them from any Jabiru dealer. Inside the distributor cap is only a rotor. There are no points, no other moving parts other than the rotor. There are 2 magnetos, 2 distributor caps, leading to 2 spark plugs in each cylinder. Spark plugs are motorcycle plugs, NGK plugs available at any auto store, any motorcycle shop, commonly found in personal watercraft, that particular plug style. Yeah, so they're available at a pretty cheap price most anywhere. The alternator produces 20 amps on the 6-cylinder, 10 amps on the 4-cylinder, and that again is a Honda design and is incorporated into the flywheel. The brass colored ring right there has 12 rare earth magnets inside it. This is the permanent magnet type of alternator. The stator is attached to the support right there. Current is fed to, again, it's a Kubota regulator. It's common in the, call it industrial engine or small tractor world, used on Kubota mowers, grasshopper mowers, anything that's powered with a Kubota diesel engine usually has that regulator on it. So if you need one somewhere in a Kubota dealer nearby, you can find parts for this engine all over the place. Carburation is a Bing altitude compensating carburetor. This carburetor is pretty common. Rotax uses them extensively in the 912 series engine. We use one carburetor, but it is a bigger size. It's a 40 millimeter carburetor rather than the 32s that Rotax uses. Works very well. In fact, there are some governments using the Jabiru engine in unmanned aeronautical vehicles, keeping an eye on some of their neighbors, I believe, up to 24,000 feet in the stock configuration. So it works very well, controlling the mixture through a wide range of altitudes. Finally, starter up on top, Nippon Denso starter, commonly used in other applications, small tractors and so forth. That is rebuildable at any auto electric shop, pretty much anywhere in the US and anywhere in the world for that matter. The Jabiru engine is a direct drive engine, and power is fed directly from the crankshaft to the propeller through a standard aircraft SAE-1 hub. So propellers having a standard hub pattern, same pattern you'd see on the small Continentals, Lycomings, is used on the Jabiru engine as well. The operating range RPM of the engine, the red line is 3,300 RPM. The 120 horse engine is now come along that it produces its 120 horsepower at 3,100 RPM, but red line is 3,300 still. Normal cruise is 2,850 RPM. Takeoff anywhere from 2,850 to 3,000 RPM is what we like to see on takeoff. Okay, the heart of the Jabiru ignition system is this magneto module that is produced by Honda, and it powers each distributor independently. It's a true magneto. It does not require any outside electrical power. It's not a capacitor discharge or CDI ignition. It is a true magneto. Magnet goes past the coils right here, excites the coils, produces a charge, and the solid state circuitry condenses the charge, feed it on down the lead to the distributor, and from there out to the spark plugs. If your alternator quits, your battery dies, it does not require any additional power. It'll run on its own continuously. Here's an example of the Jabiru alternator. This is the 20 amp alternator from a 3300 engine. As you can see, it is the permanent magnet type. 12 magnets inside the magnet ring, 12 poles on the stator here. The stator is stationary, whereas the magnet ring, the alternator body as Jabiru calls it, is attached to the flywheel and turns with the engine. Here's a cylinder head that we have off an engine right now that we're going to be demonstrating in our engine maintenance and rebuild seminar this weekend. We took this head off. As you can see, this is machined from a solid piece of aluminum billet. Valve seats are inserted in the head in a special process where the head is heated up to over 500 degrees, and the valve seats are immersed in liquid nitrogen to cool them as much as possible, and then very quickly they're put on there and pressed. It's an interference fit. The valve seats are actually larger than the hole that's cut in the head, and the only way we can get them to fit is to expand the head and contract the valve seat. Then after they're in there, they are ground to the right angles and valves are inserted. These are automotive valves, not off the shelf again, but sourced from an automotive manufacturer. The length of the stem is a little bit different than what you'd find on a valve off the shelf. So they are manufactured specifically for Jabiru, but again, they're at a relatively modest price. I think a valve is about $40. Jabiru makes their own heads, their own rocker arms, make their own push rods. They make their own camshafts, their own crankshafts, and the few items that Jabiru doesn't make, they are automotive parts sourced from the automotive industry. Here's a cylinder barrel. Again, this starts life as a 7-inch diameter steel bar. The core is cut out of it on a CNC machine, and then that core is hung on a tooling board and becomes the connecting rod. Then the machine cuts out the rest of the fins, the skirts, and everything else, smooths out the bore. These are not, this is not a straight cut in there. It is a tapered cut inside these cylinder barrels. I brought along a piston, wrist pin, and connecting rod. This is the connecting rod that is made from the core of the cylinder barrel. The cap for the connecting rod is made out of raw stock. There's not enough length in the barrel to make the cap as well. The piston, this is your General Motors World Engine piston, again with a third ring groove cut in it for an oil scavenger ring, and then the grooves for the circlips on the side here are deepened, and a stronger, stiffer circlip is used. That pretty much tells a lot of the story of the inside of the engine. Some other common parts, main bearings that you'd find on the crankshaft. When we rebuild engines, those main bearings come in a little envelope that says Isuzu on them. You can get those bearings not only from Jabiru but from any Isuzu dealer. The thrust bearings on the crankshaft come in a little envelope that says Toyota on them. Again, a common part, therefore not a very expensive part. Rod bearings are the same. Those are Isuzu's. It's very easy to rebuild a Jabiru, and from an aircraft standpoint, very inexpensive to rebuild a Jabiru. When we're talking about rebuilds, a couple of points. Jabiru does not insist that their engine be sent back to some service center for rebuild. We do allow field rebuilds. It's a very simple engine, and any mechanic who has much aircraft engine experience at all can rebuild this engine with just common tools and without much trouble. There's a complete rebuild manual that comes with the engine, and if you just follow it step by step, in Chapter 6 there's 120 some numbered paragraphs, and if you do those in order, at the end of that section your engine will be spread out in pieces on the bench in front of you. Section 7 tells you what to measure for wear and tolerance. Once you've done that, Section 8 goes into the reassembly, starting with sub-assemblies like conrads onto the crankshaft and sub-assemblies on from there. And again, that's a numbered paragraphs, and if you check them off as you go through them, when you're all done, the engine will be back together on your workbench ready to test run. One of the main advantages of Jabiru engines over some of our competitors is that we are air-cooled and we're direct drive. That makes our engines a lot less complex and a lot lighter than most of the competitors. Direct drive, we eliminate all the problems and issues with gearboxes and gears and bearings and clutches going bad in gearboxes. And being air-cooled, we eliminate water radiators, water pumps, and just a lot of other hoses and systems that add weight, complexity, and really don't give you anything additional for performance. Jabiru makes it easy to install the cooling systems on their engines by providing these fiberglass baffles, plenums above the cylinder heads. If you install them properly with the inlets lined up with the inlets in your cowl and the proper amount of inlet versus outlet area, that's all you have to do to make your engine cool correctly. You don't have to cut out dozens and dozens of pieces of tin to make baffles and put silicone gasket material in there. You just bolt these on top of the engine and it takes care of your cooling for the most part. A few adjustments here and there and you're good to go. Jabirus are available for many different kinds of airplanes. Jabiru Australia manufactures about 25 different kinds of firewall forward kits, mounts, and cowls for different airplanes around the world. That's in addition to the ones that Jabiru USA manufactures. For more information on whether the Jabiru engine is a good fit for your project, you can visit our website at www.usjabiru.com or send us an email at info@usjabiru.com or give us a call. Our phone number is 800 Jabiru 1. Be happy to talk with any home builders.
So I'm Jerron Smith with Raven Redrives. We've been in business the last 11 years doing nothing but converting the Suzuki line of auto engines for home-built aircraft. We started out in working with the 1-liter 60-horse engine that comes in the Geo Metro, and then worked to convert the 4-cylinder engine that came out in 1995 through 1997. That engine brought the horsepower up to 80 horse. And just recently, in the last 3 years, we came out with the newest model, which is the 1.3-liter 16-valve engine coming in the 98 or newer Geo Metro, which puts out 90 horse. We have over 200 applications flying worldwide and have done a very good job, we feel, in addressing a number of different issues. The main one of which is torsional resonance, which occurs anytime a piston aircraft engine is attached to a propeller with a reduction drive in between. We do a cog belt reduction, which is the lightest weight, most reliable type of reduction system that you can do, and all of our drives have a trademarked rubber cushioned system in the prop hub that allows us to dampen torsionals. A typical Rotax engine cannot idle below 2,000 RPM because of resonance issues. We can idle our 3-cylinder engine down to 1,050 RPM, and our 4-cylinder will idle as slowly as 600 RPM smoothly. And this is all due to the rubber cushion drive hub. This is our 1-liter 3-cylinder engine over here. And this is our 1000 ULRS drive. And I can rotate this. It's typical of our applications. The drive is located on our belt drives either down in the middle or up at the top, depending on whether it's tractor or pusher. And in the hub here is where we have our rubber cushioned and dampened drive hub system. So this engine in the car, it runs at a very, very high RPM use continuously. In the Metros, they run the engine in the 5-speed at 4 grand, and in the automatic at 4,800 going down the interstate at 75. So it's one of the only auto engine conversions where the engine sees in actual use the same flight RPM that it would see going down the interstate at 75 or 80. Your V8s, your Hondas, your Subarus all loaf along the interstate doing 75 at 2,600 RPM or so, and then we put them in a kit plane, rev them up and say, oh, they're going to last at 4 grand. The Suzuki's the only auto engine conversion that sees the same RPM in its daily use in the car as we are going to use it in the aircraft application. The reason that we chose the Suzuki line of auto engines to begin with is very straightforward. The Japanese produce some of the best and well-engineered auto engines in the marketplace. And this particular 3-cylinder engine that we started with is unique. It's all aluminum block, so it's the lightest weight possible with an overhead valve system that has no rocker arms. The lifters are directly on top of the valves and the camshaft right above them. And so this engine weighs the least possible weight for the amount of its horsepower of any engine that you could produce. So in comparison to the 582 Rotax 2-stroke, we are only 10 pounds heavier with a 4-stroke engine than that 2-stroke engine package. And that's just unheard of. That's the only auto engine conversion that we know of that can get down into the weight of the light plane sport aircraft marketplace. This engine also has a reliability track record that is second to none. It's like the little Energizer bunny you see on TV that just keeps going and going and going. We had a guy come to the booth and talk to us about his Geo Metro 3-cylinder that had 440,000 miles on it and was still running just fine, burning a little oil now. Typically, these engines will go 150 to 175,000 miles without any servicing. Change the timing belt, oil, spark plugs. So we can't say enough good stuff about Suzuki. They are 2/3 of the equation of a successful auto engine conversion. They developed the engine. It's been proven with trillions of miles worldwide. It has been in production 15 years with no changes. It's bulletproof. They did the engine, the ignition system, and the injection system, all of which Raven recycles. We developed the drive system that makes it all work, developed the mounts that fit the different applications, and so really 2/3 of this equation is the result of Suzuki's great engineering. So we're very, very happy with them, very satisfied with the results. And we expect TBOs in these engines to exceed 1,500 hours easily, because in the auto app they're running 3,000 hours between overhauls. So we're very, very happy with that. The next model of engine that we have here is the 1300 SBS, which is the 1.3 liter 98 or newer Geo Metro engine. We get 90 horsepower out of this particular package. And if you look, you'll see that the engine has been turned sideways. We call it our Sidewinder. We have done a lot of R&D to be able to flip the engine sideways, and the reason for that is to be able to fit in the same physical parameters and similar mount system to the 912 line of Rotax engines, because they are the most popular kits out there. So this engine, when turned sideways with a saddlebag oil pan to work with the oil, then is in a profile that will fit like Zenair 701s, Zenair 601s, Ranzess 6, all the kits that have the Rotax 912 under the cowling. So we did a lot of research and development. This engine has been out for 3 years now, and we're very, very happy with the results. We're slightly heavier than the Rotax, but with more power, and we're fuel injected instead of carbureted. So that particular engine, we're very pleased with where we ended up with that. We also are doing a new drive using the same engine but in a vertical configuration. The engine is canted about 35 degrees, like half of a V8, and The drive line is up at the top of the engine in this case. This will work on the Tiger Moth R80 from Fisher, other tractor aircraft that need the prop at the top of the cowling, and a number of pushers like powered parachutes or any application like that where we're not trying to fit it in the cowling. It's a little cheaper to do this because we don't have extensive modifications to the intake manifold and oil pan to turn it on its side. So that's a drive that's just out this year, and we plan on selling a lot of these. A complete engine package like the one here on the table installed in the Zen Air 701 looks like this. You can see it's got a power fin propeller on it. There's the custom mount that we developed for the 701, the radiator package, and it lays and fits in there just perfectly. So that's a 701 application. And there's a mock-up of the mount that we developed in our shop for the 701s with turbo. And you can get an idea of how that layout was all done, and now we're in production on that mount as well. What we specialize in is working with the do-it-yourself or owner builder. We do complete engine packages, and we do those when we have time, but 95% of our sales are reduction drive kits where the owner builder picks up their engine, computer, and wiring harness from their local wrecking yard or from the Japanese engine importers, and then mates it with our reduction drive kit, follows our great manual that we've written on doing the conversion, and ends up after about a week of work with a package that's equivalent to the competitor's Rotax 912 or 912S at half the cost. When we move to the turbo version of this engine, we end up with an engine equivalent to the Rotax 914 turbo, and we end up coming in at less than a third the cost. So that has been our philosophy at Raven, is trying to keep flying affordable by providing an alternative engine package that the owner builder actually assists in the assembly of, and therefore ends up saving a lot of money. We also end up with a better engine because of the fuel injection. The engine has a longer TBO, it's fully liquid cooled, it has no problems with altitude compensation, it has no problems with shock cooling, so it's a better package.
A great way to demonstrate the conversion of the Suzuki auto engine into an aircraft power plant is to follow a builder who is accomplishing this task. Rick Roberts has documented his Raven conversion for his new Zenith 701 home-built plane. Rick desired a viable alternative to the Rotax 912 and chose the Raven low-profile Sidewinder conversion kit using a 1.3-liter Suzuki engine with a 1300 SVS redrive unit. A suitable 1.3-liter Suzuki engine was obtained from a Geo Metro at the local salvage yard for a few $100s. This one has 15,000 miles on it. The Raven conversion manual describes exactly which engines to look for based on car model year. It is best to retrieve the complete electronic computer system with sensors and wiring harness, but if this is not available, then an aftermarket setup can be used. The first step is to remove items that will be returned to Raven for modification. The original oil pan and pickup tube are shown here. Raven will modify the pickup tube to accommodate the new saddlebag oil pan. This is necessary as the engine will be turned and mounted on its side to obtain the low profile we want under the cowl. Here is a picture of the original configuration. And this is what it looks like with the modified pickup tube. The new saddlebag oil pan, pictured here, is created from the original pan you send to Raven. The parts that are sent to Raven and returned with modifications are the flywheel, intake manifold, crank pulley, oil pan, oil pickup tube, and water outlet. An engine mounting plate, starter, and of course the redrive components are supplied by Raven. Before installing any of the new components, Several hours are expended in the process of sanding and painting the engine. It has got to look good. Assembly of the redrive system starts with installing the new lighter, balanced flywheel that Raven modifies from the flywheel or automatic transmission flex plate that you send to them. The manual clearly describes the steps required for an easy bolt-on installation. There were 3 locations that required drilling and tapping into bosses on the engine block. The aluminum is easy to work with in this regard. Everything fit perfectly the first time, Rick told us. Here is a picture of the fuel rail and injector system that was modified slightly to accept aircraft high pressure AN6 fittings and hoses. This is a picture of the aftermarket engine computer that was obtained from a third party. If you are able to obtain the original computer with the salvaged engine, you would not need to purchase this. At this stage is the final torquing of all components. Rick's wife assisted him in preparing the engine mount, which was obtained directly from Raven for his Zenith 701. Here she is supergluing washers onto the engine mount. 10 bolts have to be guided in at the same time. Rick used an engine hoist to assist the installation. It was a problem-free, easy installation. Here is a close-up of the fuel rail. It sure is nice having a reliable fuel injection setup. No carburetors or icing problems with this stock system. These are the ignition spark modules mounted on the firewall. Here are the dual high-pressure fuel pumps. This is the fuel header tank gas collator that the wing tanks feed. It was custom built for Rick's installation. Rick is currently plumbing the fuel system and expects to be up and running soon.
Excellent. Where is it turning?
So, to give you an idea of the process involved for the owner-builder is, most people, in the initial phases, they purchase our instruction manual. We've written a great manual that's picture by picture. Chapter 1 is going to your local auto wrecking yard, selecting the correct engine, computer, wiring harness, which is the lightest starter that Suzuki made, this lightest alternator. Also picking up and recycling the computer and wiring harness. And it shows you step by step going to the wrecking yard and getting all those items. And then once a person has the manual, they pick up the correct engine, computer, and wiring harness, order our drive, and then follow the sequence in the rest of the manual to modify the computer, the wiring harness, make all the necessary changes, but it's picture by picture. So typically, for the 3-cylinder package, a guy will spend $300 to $500 for a used late model low time engine, computer and wiring harness, pick up our reduction drive kit for the 3-cylinder, which varies depending on the application between $2,100 and $2,600, and end up spending in the end somewhere between $3,000 and $3,500 for a 4-stroke alternative auto engine conversion. So once again, we're always more affordable than the competition. An HKS is $8,000, a Rotax 582 is $5,000 to $6,000. So we come in allowing the owner builder to provide himself with an affordable alternative. If we do the 4-cylinder engine, typical engine costs at this point are between $600 and $1,000 depending on mileage for the engine, computer, and wiring harness. Our complete drive kit with modified oil pan, intake manifold, lightweight starter, and custom exhaust for their application is currently $46.95. So they'll end up spending about $6,000 for their package with radiator, fuel pump, engine, computer, wiring harness, and our drive assembly. So they ship us parts from their engine, their intake manifold, oil pan, flywheel, coolant outlet, and all those parts come back as part of this kit assembly, modified, painted, and ready to bolt on to their core engine. So that would put their cost at about $6 grand for a 90 horse engine equivalent to the Rotax 912S, which currently retails for around $13,000 to $14,000. So once again, less than half the cost, and they'll spend a week of their time putting it together. So to us, it's a very affordable way. Most guys nowadays do not want to spend $12,000 on their kit plane kit and spend $13,000 on an engine. We provide that affordable option that allows them to spend what we consider to be the correct ratio. About half the cost of the kit, $6,000, would be the cost of the engine package. If you want to contact us, you can reach us on our website at www.raven-rotor.com, which is our main website. Has all the redrives listed, information on our instruction manual, information on our new rotor plane and rotorcraft area. And also there is listed the email address, which is info@raven-rotor.com. And then you're welcome to write. But the best thing to do if you want to get your questions answered is to call me directly. On our Colorado number is 303-440-6234. And if I'm traveling or down at our Taos, New Mexico research and development facility, that'll forward to my cell. And you'll be able to reach me directly. So yeah, feel free to call with questions.
Hi, I'm Mike Templeman. I own Stratus Incorporated. Purpose of our business is to provide experimental aircraft alternatives to the Rotax and the higher priced engines. The reason we chose Subaru is because it's water cooled. When you have a water cooled engine, it lasts a lot longer, a lot less wear and tear. Also, with those who have played with it, they've learned that they can get excellent fuel consumption, all kinds of power from low end to top end. So that's what we try to do, is provide a good practical engine at less money for those who are looking to have an engine for their experimental two-seaters or ultralight aircraft. I worked for NSI for 5 years, built their engines, but didn't like the way they ran their company. So I had the opportunity to buy out Reiner Hoffman 7 years ago. So I bought Stratus, and he had built about 110 engines, and I have so far built about another 45. And so I have 177 previous engines under my belt, so I know Subaru quite well. The reason the EA81 was chosen was it's a good basic motor. You'll discover that if you see Subarus on the road, some of them, the bodies are rotted off of them, but the engines are still running great. These things will go 200,000 miles and still run fine. Reason a water-cooled engine has an advantage is because it has a lot less wear and tear on the cylinders compared to an air-cooled style engine like a Volkswagen. You can get a little more weight is what your sacrifice is, but you're getting more dependable horsepower, and the engine's going to last you a lot longer. The whole engine is aluminum with steel sleeves. It's got a tough-dried steel crank in it. It's just a standard pushrod motor, but very dependable. The total package weighs 200 pounds, including the drive, starter, carburation, and a muffler. Basically, it's the configuration was one that worked out real well, so it's been quite a popular unit, and we bought up all the cores that we could. We've got a warehouse with about 90 engine cores available. Previous to buying Stratus, I did work at NSI, and we had a Superflow dyno. The engines that we built there were almost identical to these, although had their throttle body inlets rather than the Bing carburetors. So I have run this style engine on a Superflow dyno. At 5,900 RPM, they develop about 105 to 106 horsepower. Although that's not what you fly off of. You fly off of the torque that comes in right off of an idle and is almost a flat line throughout the RPM range. I also tell my customers to set their pitch at about 17.5 degrees so that it'll load the engine statically at about 5,000 for a good takeoff, and then you cruise at 38 to 4,200, and that way you'll get about 3.2 to 3.5 gallons per hour. Okay, the Stratus engine is based on a basically stock bottom end, although we put a mild cam in it. So we start with a core engine, totally tear it down, have the rods matched, the crank polished, we have the heads rebuilt. We take 50 thousandths off the heads to bump the compression slightly. But all the main components, main bearings, rod bearings, water pump, oil pump, are all stock components that you can buy at an auto parts store or a warehouse, or I have the stuff in stock if you can't find it locally. Other than that, we have the reduction drive casting made to bolt onto the block in place of the bell housing. Inside this drive is a bearing that supports the end of the crank, and it has the flywheel seal in the outside end of it. Aluminum flywheel. The starter is over the top of the engine to keep the weight centered over the top of the engine. We make our own intake manifolds. We make our own alternator brackets. We make our own engine mounts. And then we also make the second ignition that's an option. And we make a nice stainless steel muffler. I don't have any with us today. This one's just for test running the engine. But a stainless steel muffler that's slip fitted on one side so that it won't crack or break on you. Use a 55 amp alternator that's a lot smaller than stock was on here. And then we use Bing carburetors because they're altitude compensating. We do buy them brand new, but they're rejetted for this application. Although they have bigger jets in them that a Rotax would have, this engine uses less fuel because it's run at lower RPMs. Some people ask us why a belt drive. Basically, it's because it's simple, it's easy to maintain, They have very little problems. You can see all the parts from the outside. I've been around other companies that had gear reduction drives, that had sprayed clutches, that claimed that they weren't sprayed clutches, and the problem with something like that is you have metal on metal pounding on itself, and eventually it'll fatigue and break. I've seen many go away. Even some of the other vendors that had transmissions that they thought they could use a stock flywheel and a spline to engage them without any clutch have now found that that is causing problems for them also. So basically it's simplicity. The belt doesn't eliminate all the torsional vibration, but it does dampen it, and with a 3-blade ground adjustable prop, these work quite well. Our reduction drive is at 2.2 to 1. The reason we chose that is because the RPM ratio between the engine and the prop is just right at that speed. If you ran a prop direct drive off of one of these engines, you'd either be overspinning the prop or lugging the engine. So the idea is to get the prop tip speed where it's most efficient and not cavitating the air but pulling you through most efficiently, and that the engine RPM maintains the speed it needs to stay alive and perform well. So 2.2 to 1 at 4,000 RPM, you're spinning the prop at 1,700 approximately. That way you're getting the proper ratio between tip speed and engine speed. Okay, we get lots of people calling and asking what the options are with the Stratus engine. First of all, I sell the complete running engine, test run on a bench, carburetor synchronized, the timing set, and then I'll drain the fluids and mount it in a crate. The price of that is $77.45 plus shipping. If somebody has their own engine, they can either send me the core and I can build theirs, and they may save themselves $150 to $300 because that's what the core's worth. Although what you find out is by the time you pay freight to get it to me and get it back, you've spent more than you could have just bought one from me, and I do have plenty of cores to work with. The other options are we do sell the reduction drives, the carburation, the engine mounts, the alternator system, and the second ignition and a muffler, so people can build their own engines, and I'm happy to tell them what we do. We're showing here our 55 amp alternator that's a lot smaller than stock for the Subaru. It's an Ippendenso brand. We make the mounting bracket, the adjusting bar, and a bracket that bolts on the water pump to mount the adjusting bar on. And then we use the cog belt with the little dimples in it for ease of spinning and bending at that angle. And then we have our reduction drive with a 4-inch prop extension. If you have an avid flyer, we use a 2.5-inch extension. The upper and lower pulleys are both hard coat anodized so that the belt won't wear into them very easily. Remanufactured starter, aluminum flywheel with a plated ring gear. We do have to make our own bolts. We use 3/8 bolts and then cut them down and thread them to 11 millimeter to fit in the crankshaft. And then we have our Bing carburetor kit. We make our own intake manifolds and thermostat, and you have the new Bings with air cleaners and the rubber boots that we use. It includes all the hoses for water and crankcase ventilation from valve cover to valve cover. This is showing some more of our components. We put a remanufactured electronic ignition distributor and new spark plug wires on the engines. The option is our second ignition, which is an MSD coil selector, our ignition box, and a pickup and 2 coils, so that your primary ignition is running to 1 coil to an MSD coil selector. Your second coil is going to the side of the MSD coil selector, and then that's feeding your distributor cap. We have an engine mount kit, which is all the biscuits, the upper mounts, and I'm just showing you your lower mounts before we put them on a jig and weld them together. We have all the pieces laser cut, and then we make the parts ourselves. We put a mild cam in them. If you send me your cam and lifters, I'll be happy to have it ground, parkerized, and the lifters ground, and it's sent back to you. Also, when we do the valve grind, we do a little more than a standard valve grind. We replace all the guides, but we also cut a groove in them and put a clip on them to hold those guides in place, so that if for some reason you overheat the engine, it's not going to swell the valve guide on the valve stem and start moving it in the head. So basically, you can buy the drive for $26.95, the carburation for $16.95. Our engine mount package is $265. Our alternator kit is $265. The second ignition is $416, and our stainless steel muffler is $525. The only other option one might buy is our rebuilt distributor that comes in the engine, and those run $350 exchange. Those are a Nippon Denso. They also used Hitachi in those model years, but Hitachi doesn't have the same advance curve and doesn't work as well, so I'd stay away from that. When we build the Stratus engine, I don't want anybody to get it without me knowing that it works well to begin with. Two of the things that I'm concerned about is making sure that the carburation is synchronized, and that the low-speed idle mixture is set, and that the ignition timing is set. That way, a customer is not going to install it and then have a problem and wonder what happened or where to set it or how to set it. So when we finish an engine, I mount it on the stand, put oil in it, hook up the ignition, put water in it, and run a bypass system so I can check the thermostat for opening also. We fire up the engine and basically do a basic tune-up, and I check the second ignition at the same time to make sure it's functioning. Here's a customer's engine that I just finished. Everything's hooked up. I've had it running so I don't have to choke it. Normally when it's cold, you choke one carburetor for just a moment and it'll fire up. As soon as it warms up, I synchronize the carburetors and set the idle mixture by using a unison between them to make sure they're synchronized, and then I'll set the timing. I hit the ignition, make sure the fuel pump's working. Once the engine's warmed up, I'll go through a little bit of throttle acceleration. I'll shut it down and then start it after it's warm. I'll let it cool down and start it again. Make sure that it functions. Check it for leaks. Some people are curious on how we tension the belt or align the pulleys. After the first 25 drives were made, Reiner decided to upgrade them with the ability to adjust not only the tension but the alignment of the pulleys. If you understand that we have a centric for tensioning up the pulley, one in the front of the shaft and one in the back of the shaft, you notice the front one has a flat sides on it so that we can put a wrench on it for adjusting the tension. And the back one goes around your lock nuts and has a 1/4 inch pin that fits in a hole in the back centric. What happens when we tension these up is we go to the left side of the engine and lift up on it this direction to tension the belt, and at the same time we hold the front wrench and pull down on the back wrench, and what that does is allow the nose of the pulley to camber just enough to get that pulley aligned with the bottom pulley. What we're doing is measuring the distance between the upper and the lower pulley by going between the pulleys and in 1/2 inch, and then measuring with a dial indicator. Get that measurement, double check it 2 or 3 times to make sure it's correct, and then go in the same groove, go to the back of the pulley, pull it forward 1/2 inch, set your calipers on that one and measure it. And if you're within 2 to 3 thousandths, that belt is going to ride perfect without walking one way or the other. When Reiner Hoffman first developed the EA81 with the reduction drive and the Bing carburetors, he had an Avid Flyer, and once he ran that and knew that it functioned well, he wanted to see how it compared to an 0200 in a Cessna 150. So he installed one in a 150 and got better fuel consumption, a little better speed, and a lot less overhead in maintaining the engine. We've sold lots of them to Avid Flyers, Kit Fox 4s and 5s. Genesis ultralight, the 601 Zen Air. I have customers that have put them in a Rans S7 biplane. They've been in some airships. So anything that a 200-pound package can bolt on will work fine. It's just that you may have to build the attachment frame, 2-hour engine mounts to get it to be mounted properly. Sometimes people are asking why use a Subaru in an airplane, and the simple answer might be because Subaru did. Although apparently business wasn't really good and they didn't stay in the market long, but they had the configuration, they had the engine design, and they had their own aircraft for some time. Anyway, as you know, and have seen many of the ads, Subaru engines are very dependable and reliable, and so that's why we went to them. A water-cooled engine works really well, the shape was good, and the reliability is there. We have an ad in Kit Planes magazine in the back that does have our website, which is www.stratus2000.homestead.com. It's got our home phone or business phone in there. It's also a fax, so 541-754-4114 would get a hold of me. Email me at mjt@camano.net, camano.net. And leave a message if I'm not here. I'd be glad to call you back in the evening.
Wow, I've learned a lot about engines. I'm going to contact those manufacturers and I'm going to tell them that Home Built Help sent me.